Alright, so we're going to continue on with Unit 2. In this lecture, Lecture 2, we are going to discuss the basics of the periodic table, how the periodic table is structured, organized, arranged, however you want to look at it, and the specific layout of our modern periodic table, and we'll point out things that you need to know really well so that we can continue on with learning chemistry. Alright, so let's look at the essential question of the lecture. How is the modern periodic table of elements organized? This is a must question that you need to be able to answer, and of course have down packed so that you can answer the questions that will become on the quiz. Alright, so let's start with learning how our modern periodic table is organized, just the basics. So the first question is, how is the modern periodic table organized from left to right? Well, that is simply by what is known as the atomic number. Okay, by the atomic number. We'll learn more about what the atomic number is later, but essentially it is the number of protons that an atom has. Alright, and we'll look at this on the periodic table in a minute. Alright. Number 2, why are elements placed in columns? Well, columns basically run up and down the periodic table, or from top to bottom. And columns, elements that are placed in columns on the periodic table represent special groups. A special group or family okay. Now these groups or families are based on, so groups are based on having similar chemical properties. Okay, so again, elements are placed in columns which are known as special groups or families, and these groups or families are based on elements having similar chemical properties, going up and down or top to bottom on the periodic table. So what exactly are periods? Well, periods are arranged moving across the periodic table. So periods move across the table from left to right. And there are 7 periods on the table. And we'll show you those in just a minute. Alright, next question. What does it mean for an element to belong to a group or family? Well, as we mentioned before, when an element is put into a group or in a family, it is because that element has similar chemical properties. Okay, as other elements in the same group. Okay, so this is a really important question to understand. So again, elements are placed into groups, and those elements that are in a group have similar chemical properties. Well, how many groups are there on the periodic table? There are 18 groups, or families. Now, in a minute, we're going to look at a periodic table, which is in your notes, and we're going to look at a specific dividing line that exists between different types of elements, and that dividing line is important for you to know and be aware of. And again, we'll show you this in a minute, but that dividing line separates really the metals from the nonmetals. And so elements to the left of the dividing line are known as metals. Whereas elements to the right of the dividing line are known as non-metals. Right? And then elements that are along the dividing line, and we'll point these out in a minute, are known as the metalloids. And what are metalloids exactly? Well, metalloids have basically the properties of both metals and non-metals. Alright? Okay. Let's see here. See if I can bring up, here's our periodic table. Alright, so here's our periodic table of the elements that's in your handout. And there's some things that I want to point out to you. Okay, so going across the periodic table, you will see that there are groups. Oops. What's that here? All right. There are groups. There's the groups across the periodic table, and you will see that if you count them, there are 18 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth. And so each group, this is group 1, group 2, group 3, group 4, and so forth. And remember, elements are grouped into groups based on their chemical and physical properties. Okay, I'm going to erase these arrows because we're going to fill in some other things here. These as well. Alright, and then along the side here are the periods. And there are 7 periods. And the periods, remember, they go from left to right over the periodic table. So these are all periods. This is period 4, period 5, period 6, and period 7, going across the periodic table. Alright, let me get rid of that here. Erase all this. Right. So now we also said that the periodic table is arranged by the atomic number. Well, looking at here, the atomic number at our key for hydrogen is number 1. And you can find the atomic number for all the other elements right above the symbol. And so you'll notice that hydrogen is our first element. It has an atomic number of 1. Oops. Whereas you'll see that helium has an atomic number of 2 there, and then lithium has an atomic number of 3, beryllium 4, 5, and 6. So going from left to right across the periodic table is organized by atomic number. Alright. And then we said that going down, or from top to bottom, the periodic table is arranged by groups. So again, group 1, group 2, 3, 4, 5, and so forth, all the way to group 18. And remember, why are elements placed into groups? Because these elements have similar chemical properties. So if you look at group 18, you look at helium, neon, argon, krypton, and xenon. These elements are all grouped together because they have very similar chemical properties. And if you look at group 1, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, they're all grouped into the same group or family because they also have very similar chemical properties. So again, in summary, the periodic table, the modern table, is arranged by atomic number going from left to right, whereas it is arranged top to bottom into groups or families based on similar chemical properties. So make sure you really understand that concept. It's very important. Alright, now let's go to that dividing line that we were discussing earlier. If you look closely here at our periodic table, underneath boron and above aluminum, there is a dark line, and I'm going to trace that line with this highlighter. And that line right there is our dividing line in the periodic table. So everything that is left of this line right here are known as the metals. And everything to the right of this line are the non-metals. Okay? And it will be important that you know where the metals are, where the non-metals. By far, the most elements on the periodic table are the metals. So all of these are all metals that you see. The only exception to this is hydrogen. Hydrogen is considered a non-metal. Okay, so make note of that. Hydrogen is indeed the only exception. Everything else, though, to the left of that dividing line is a metal. And everything right of that dividing line is a non-metal. Make sure that you memorize that dividing line and know it well for the quiz. Alright, so what exactly are metalloids? Let me erase all of this and let's look at the metalloids here. The metalloids run along the dividing line. They can't make up their mind if they want to be a metal or a nonmetal. So they choose to be both or have properties of both. The common metalloids that you need to know for this class are going to be boron, silicon, germanium, and antimony. Okay, these are the 4 metalloids that you have to basically know for the test or this class. Again, boron, silicon, germanium, and antimony, they're metalloids. They're found along the dividing line, and they have properties that are both similar to metals and nonmetals. Alright, let us see if we can go back to the PowerPoint here. Okay, and finish this up. Alright, so we just talked about what metalloids are, and knowing that metalloids have properties that are similar to both metals and nonmetals. And the ones that you have to be familiar with are boron, silicon, germanium, and antimony. Now these 2 right here, silicon and germanium, are the 2 most commonly tested metalloids on any chemistry exam. So make sure you definitely know those 2 really well. Alright, so let's look at properties between metals, nonmetals, and metalloids. And fill in this table here. First of all, let's look at density and related to metals. Metals have typically high densities. They have high melting points. They have very high boiling points. They do conduct electricity. They do conduct heat very well. And they are considered malleable. Now, what exactly does it mean to be malleable? It means that the metals are bendable. They can be flexible. They can be put into any kind of shape or so forth. Be familiar with what malleable means. Metal reactivity, they like to react with non-metals. Alright, so there's some properties of metals to be familiar with. Now what about the nonmetals? Well, the nonmetals are really easy because they're essentially the opposite of metals. So when you look at their density, they usually have low densities, low melting points, low boiling points. No, they will not conduct electricity. No, they will not conduct heat. And they are brittle. In the solid form, they're brittle, which means that they crumble or break apart. They are not flexible whatsoever. They completely crumble. And they're reactive with, you guessed it, metals. Alright? Now, the metalloids we've already kind of discussed. The metalloids essentially have properties that fall in between those of metals and nonmetals. And that's essentially all you need to know about the metalloids, other than to give examples of the metalloids themselves. Alright? So this pretty much really ends Lecture 2 on the periodic table, or the basic organization and structure of the periodic table. I would strongly recommend that you go back and re-look at this lecture video. Make sure that you understand how the periodic table is organized left to right. Remember, left to right, it is by atomic number, and top to bottom, they're grouped into groups based on their chemical properties. And so all elements within a group have similar chemical properties. Remember that there are 18 groups, there are 7 periods, and be able to identify an element's group and period number. So if I say carbon, the element carbon, you should tell me that it's in group 14 and period 2. If I say magnesium, you would say it's in group 2, period 3. So be able to do that skill as well. All right. So this should end this particular tutorial session.